Our next speaker is Dr. Lynch from Children's Hospital of Philadelphia. Dr. Lynch is a graduate of Yale University, majoring in molecular biophysics and biochemistry, and obtained his MD and PhD at the Johns Hopkins University School of Medicine, graduating in 1988. His PhD thesis was on processing of endogenous opioid peptides. He completed internship and neurology residency at the University of Pennsylvania, followed by a fellowship in molecular pharmacology, neurogenetics, and movement disorders at the same institution. He was appointed to the faculty in 1995 as an assistant professor in neurology and pediatrics. He was promoted and received tenure in 2004 and promoted to a full professor in 2010. He has published over 250 scientific papers, mainly on NMDA receptors and anti-NMDA receptor encephalitis and Friedreich's ataxia, with greater than 23,000 citations. He has been continuously funded by the NIH since 1994 for basic science, clinical science, and translational projects. Dr. Lynch, thank you so much for taking the time to be here today, and I will now turn the time over to you.
Thank you, Sarah, and thank you very much for that lovely introduction. It has a lot of numbers in it. I think the worst one is 1988 and completing residency, which means that now I am old. So I'm going to try and share my screen now, and this is where we always have our issues. Share, and then we go over here to the full screen. And are you all seeing full screen yet or not? No.
I am not yet.
Okay. There you are. Very good. So we're going to talk about a little bit about Friedreich ataxia, some new treatments and new mechanisms. I may amplify on a few things based on our experience at CHOP, where we now follow roughly 500 people with Friedreich ataxia. And within the natural history study, which I'll refer to later, we have enrolled between 700 and 800 at this point. So we see a lot of people with FA. Let's see if I do this correctly. Yes, I get a grant money through CHOP from the NIH, FDA, Friedreich Ataxia Research Alliance, the MDA, Reata, PTC, Design, Self, Voyager, and Larimar. None of them are directly on the topics I'm going to talk about today for the most part. I'm not going to talk about any off-label use of medications. As many people are aware, Friedreich ataxia is a rare progressive neurogenetic disease affecting roughly 1 in every 50,000 to 1 in every 100,000 people. That gives rise to an estimated roughly 4,000 to 5,000 people in the United States, maybe 15,000 people worldwide. There have been attempts to sort of revise those numbers up, but I actually don't really believe them. I really think the original numbers are pretty close to correct. The usual presentation always involves neurologic features. Everyone has neurologic features if they live to the typical age of onset. However, it is truly a multi-system disease. As you heard, as Dr. Komdar talked about the cardiac disease. Not everyone is the same with FA. The most common presentation is in childhood, sometime between the ages of 5 and 15. It is associated with more rapid progression, and the earlier we meet you, the earlier you present, in general, the faster you progress, becoming with people who present early in life, by late teenage years or 20 years, they'll be wheelchair bound and require assistance for their activities of daily living. There are about 20% of individuals present after age 15 and maybe 10% after age 25. They have demonstrably slower progression and demonstrably milder phenotype. In particular, they rarely have significant cardiomyopathy. They may have flipped T waves, they may have subtle echo changes, but they never go anywhere. So that's the individual who can not necessarily follow the rules we have of imaging every year and lab testing every year. So not everyone with FA is alike. Classically, we're neurologists. We think about what is involved. The earliest thing is the loss of sensory neurons, which get what we call proprioception, the sense of where your body is in space. That gives rise to a loss of deep tendon reflexes. And we think that if we met every child with FA at age 1 or 2, they would have lost their reflexes by that time. And associated with this, you get loss of some other tracts in the central nervous system, the spinal cerebellar tracts, which take information to the cerebellum, which is concerned with coordination. You also, and people forget about this, lose the large motor tracts slowly over time, the ones that are also lost in ALS. It is not as complete as the cerebellar loss, but it can be problematic, particularly after people become wheelchair bound. You lose a particular part of the cerebellum, which is the output nucleus, the output location called the dentate nucleus. That is where one of the trials we're doing now is attempting to replace the gene by direct injection of a gene in there. This will give rise to dysarthria, slurred speech, some eye movement abnormalities, it gives rise to further ataxia beyond just the loss of proprioception. It's not always appreciated that people who present early lose their vision. About 20% of people who present with FA will eventually go blind or have clinically significant visual loss. People get a very unusual hearing loss in which they can hear what's going on, but they can't figure out who's saying it, so they cannot localize anything in space. This can be as disabling as not hearing at all. People do have issues with muscle, but their muscle does not degenerate. It is metabolic or subclinical. People aren't really sure. As you see some of these agents which are targeted to the heart, realize that they will probably also get to skeletal muscle and make people slightly better during the ambulatory phase of the disease, early in the disease. But they may not do much later because once you lose your balance, improving muscle doesn't help very much. Overall, you largely spare your cerebral cortex, which is concerned with thinking. You can spare your cerebellar cortex, the outer parts, which are the main integrative unit of the cerebellum. So people end up having relatively normal cognition. There is a new school of thought that there is some cognition involved in the cerebellum, but it's not the typical memory and those sorts of things. And in FA, it is less impressive than in other ataxias. So overall, you have a relatively loss of a very few neurons, a modest normal axonal tracts. MRI scans very early in the disease are read as normal. And we have to do very precise matching to really see what is actually changing in FA on an MRI scan. I will mention there are other systems involved. We heard a lot about cardiac hypertrophic cardiomyopathy here. I will note, and this was relevant to that chat, what defines cardiomyopathy varies on how far you look. If you define cardiomyopathy as simply inverted T waves, 90 to 95% of people with FA have cardiomyopathy, but 40% of those people are never dying from it. If you define it as having an abnormal echo, roughly 70 to 80% of people will have cardiomyopathy. If you define it as people who are destined to eventually pass away from heart disease from FA, then about half to 60% of that. So it depends on how you write the definition. I would note that also the people with FA, their troponin levels are elevated almost all of the time in those early onset patients. About 30% of those people presenting before age 10 have troponin levels if you just send them to the lab with nothing else going on. So the meaning isn't the same as it is in me, a person who's borderline diabetic with high blood pressure, high cholesterol, and has had a previous bypass. A troponin to me means I'm having a heart attack. In FA, the meaning of a high troponin isn't always clear. And when we look at it long term, it has almost no predictive value on what is going to happen to someone. Shannon McCormick's going to talk after me about diabetes in FA, so I'm not going to talk anything more, and skeletal abnormalities, other than say that about 25% of people in the earliest onset group will get corrective surgery. People get higher feet past caregivers, but that's not particularly important. It probably doesn't change phenotype. Everyone essentially has fatigue. That is to say, they feel tired all the time. So that is a very important symptom of the disease. At present, there's no treatment to stop progression fully. We have a lot of clinical trials of small molecules which are designed to reverse the features which are downstream of the primary abnormality. Omavaloxolone is just the beginning of those. More important, there are a variety of trials that are now coming about which replace frataxin, the deficient protein. So what is the main thing we do? As Dr. Kamdar emphasized, we still follow people with the yearly echo EKG, looking for glucose and hemoglobin A1C to see if people have turned diabetic, scoliosis screening, vision and hearing screening, not necessarily looking for FA issues, but looking for other things we can treat, as well as rehabilitative services. I will tell you briefly what FA causes FA, because to understand the clinical trials, you sort of need to have a background on it. What happens is that in this mutated gene called the FXN or frataxin gene, there's a long expansion of GAAs. You might be able to see my pointer, which are between the first two exons. So they're in the part which doesn't become protein, but they keep the mRNA from that gene from being made. They silence it. Normal numbers are less than 30. FA genes are 100 to 1500. The longer it is, the bigger the problem. About 4% of people don't have that. They have one of these expansions, and then they have a single change which makes no frataxin. There is one person in Turkey who actually has two of these point mutations. We're not going to talk about that person today. Actually, it's two people because it's two siblings. But the fact that a point mutation gives the same thing as this GAA repeat, which is the abnormality in 96% of people, tells you it's not actually the repeat, it's the fact that the repeat keeps you from making frataxin. It's the loss of the protein, which is the problem. So if you replace that protein, you would have the ideal treatment. That's why there's so much emphasis on trying to get the protein back without necessarily trying to recover the RNA. In the past year, we have discovered I will mention one more thing here, is that the severity of that GA repeat length determines how bad your disease is. This is from Alessandro Durer's original New England Journal of Medicine article in 1996. So that's 30 years ago. I think it's 30 years ago this month. It looks at the age of onset in people with FA and their repeat length, the shorter of their two. And you see roughly a line between how early we meet people and how severe their repeats are. What that means is the shorter you repeat, the milder disease you have. The people who have repeat lengths of roughly 100 will first show up in a neurologist's office at age 50. The people who have repeats of 1,000 as their shortest one will show up in a neurologist's office at age 5. So that GA repeat length is very important. There's something we have learned in the past year, though, and I'm going to try and explain this, and I expect to get questions. You have to have two mutations to get Friedreich ataxia, one on each allele. So usually you have two GA repeats, that's 96% of people, and there'll be different lengths because we can size these down to within plus or minus 3 in some cases. But an interesting coincidence occurs. In 15% of people, both alleles, both mutations are the same size. That seems really, really strange, doesn't it? You wouldn't think that would occur by chance. Well, Dr. B.D. Chandani, who's at Oklahoma, and I decided to investigate this, and we sent blood on a lot of these people who have two of the same size. And what happens is that's not actually what's happening. What's happening in 2/3 of those people who have alleles of the same size is that, in fact, one allele isn't showing up. The reason it's not showing up is because that GAA repeat is interrupted. It's not all GAA, it's got GGAs mixed in the middle. We think this makes the disease milder, but we're not sure of that. But there's one thing it does for sure, that GGA keeps the mutation from showing up in the genetic test. As a result, you only get one allele showing up in the genetic test, and you think you have two of the same size, when in fact you have two of different sizes. The second one still causes disease, but it just isn't showing up in the test. So you're missized. That's a nice research issue. But the real issue is that we're missing about 10 to 15% of all carrier alleles as well. So if you were carrier tested in one of these individuals where the diseased individual has two repeats of the same size, then the carrier testing is unreliable. We might be calling some people who are carriers not carriers. So those individuals should consult their physician on whether they need to be retested. It also gives rise to the phenomena where one of the parents because their expanded allele doesn't amplify, might look like they're not a carrier. But we know both parents of a person with FA must be carriers. There are no new mutations, essentially. So when you find one parent is not a carrier, it's probably a lab error, not a, we'll call it a social error. Uh, that's something that Dr. Biddy Chandani and I have discovered in the past year. We published it about a month ago. If you have questions, ask your doctor or have the doctor email me. I mentioned this for taxon loss. It really causes it. You miss the protein. This is up to normal uh, blood cells for FRDA, for Friedreich ataxia affected blood cells. There's a lot less here, about less than 5% of normal. That's all you need to know. People do have some frataxin. It's knocked down, but not knocked out. They don't get any funny frataxin. People who are carriers have 50% of normal, but they can never get disease. It is because to get disease in a cell, both alleles must be off, and that can never happen in a carrier. What does frataxin do? It goes into your place in your body called the mitochondria, and it carries electrons so that you make energy. That's all you really need to do right now. It probably has other functions, but we're only learning about them right now. So how have we moved forward in Friedreich ataxia? Well, if you go to the FARA website, Friedreich Ataxia Research Alliance, and look at their so-called pipeline, you'll find lots of drugs in development. Why does that happen when the disease only has 4,000 to 5,000 people? Well, it's because of the FARA Natural History Study, which has provided a roadmap for the disease. There are about 10 to 12 sites in the United States, about 35 sites worldwide that have been collecting data serially every year for the past up to 24 years at this point. That gives an amazing roadmap, which allows companies to ask the questions of what do we expect if we look at this severity of disease at this age, et cetera, et cetera. Companies like a roadmap. Better yet, a GPS system, and it's getting close to that. We have detailed neurological data, quantitative measure. We save everyone's DNA for looking for other genes that influence the phenotype. We save tissue that can be assayed by companies and by other individuals to advance the science. We've received support through the years from FARA, the Muscular Dystrophy Association, the FDA has supported our project, and of course the European Union for their parallel study. That's why we have 20 pharmaceutical companies with very active programs. Oops, I went the wrong way. Key study published about 5 years ago, approved 2.5 years ago, MOXIE, the trial of omaveloxolone, also called Skyclarys. It showed that basically this drug was beneficial. We enrolled people who are adults because there's no safety data on children at that time. And there wasn't going to be safety data at that time. People either got drug or they got placebo. We looked at how do people do based on a quantified neurologic exam. And this is that data. Down is good on this slide. The placebo group is in white. It gets better for about 12 weeks, and then it gets worse. The slope of this line here is exactly what we had seen in the natural history study. So it shows that this all beginning is placebo effect, and then people are progressing as expected. You look at the people in blue who are on drug, they get better for 6 months, and then they stay the same. We will tell you now they stay the same for about 2 years on average, and then progress very slowly. This difference here between where the placebo group is and where the drug group is about 1.5 years of progression we know from that natural history study. So the way I phrase this to patients is imagine yourself going back in time 1.5 years. Imagine yourself holding it for about 2 years. That's not bad. It's not perfect, but it's not bad. You can also show the drug works using directly that natural history study. This is a paper we wrote with the group at Reata, who originally owned the drug, Angie Goldsberry and Colin Meyer there. And in black here, you have people's neurological exams worsening over 3 years as they went to their natural history visit. Then the people who are in the study who got omaveloxolone, now called Skyclarys, you see that they do better. Most in the first year, they do better in the second year. By the third year, the benefit is still increasing, but it's not quite the same. So you see that over time, this is a different way to prove that the drug is being beneficial. Now, this is not a perfect experiment. We call this propensity matched. It doesn't account for the fact that people who enroll in a natural history study are not matched to people who enroll in a clinical trial. You can never get around that. So this is good confirmation that the drug works, but it's not good primary proof. Placebo groups are very important. That's something we always have to remember. Ongoing now, since I'll talk about new clinical trials, the drug omaveloxolone has been bought by Biogen now. They're taking the drug forward into children. There are two ongoing trials now, one called BOLD, where they're trying to figure out if kids need the same dose, and BRAVE, which they're trying to look against placebo to see if it is beneficial. In the BRAVE study, it's 2-to-1 against the same adult dose of omaveloxolone. Again, looking at how well they stand as the primary outcome. There's an open label extension now, and if you are interested, there are about 5 or 6 sites enrolling around the United States now, as well as if you're listening from other places in the world, there are sites enrolling in Europe, Australia, and I believe in Saudi Arabia soon, if I am correct. Although I'm sure people from Biogen will correct me if not. The B theme is good, bold, brave, Biogen. Think about what the next trial will be called. Use your imagination. Other trials which are enrolling right now, or not one which isn't enrolled, the first one isn't enrolling. You will recall vatiquinone, originally discovered in the Vatican, so that the accent goes on the first syllable for those who are linguistic aficionados. It works by inhibiting some of the downstream pathways from frataxin, so it doesn't change frataxin levels. It was disturbingly safe in its study. It did not have enough benefit, though, in the FDA's mind. We're going to see what happens. It is still, I think, a viable drug because it was so ridiculously safe. I think I call it disgustingly safe, but people don't like it when I say it that way. We'll see where it goes. I wish it were available, but I don't get to make the rules. Nomlabofusp. A little applause for my pronunciation. This is an injectable form of frataxin, you might say. It's a substance called tap frataxin, where frataxin, the protein, has been altered to put a little piece on one end so that it enters cells. It's a daily injection. It restores frataxin levels in peripheral tissues. There are two questions about it. Does it get everywhere? It appears not to cross the blood-brain barrier, or it certainly doesn't cross it very well, so that it could be a very good heart drug, and that's what it does in FA mice, is corrects heart disease quite well. It could go to the skeletal muscle, but it's not destined to get to the cerebellum and the corticospinal tract. So it has a question, it won't really get there. The second issue is it has immune issues. You do not make tap frataxin in your body. You make frataxin. You don't make tap frataxin. As a result, you will have an immune reaction against mainly the tap part, presumptively. Their press releases have shown that there are significant immune issues. For this to move forward, one will have to figure out what the real rate is and figure out how to distill that in terms of its proposed and putative value. Because I just mentioned, because it does not distribute everywhere, its value is not infinite. In fact, it's limited to heart and peripheral tissues most likely. So figuring out how to balance those is the question moving forward. Another way to make more frataxin, gene therapy, put a new gene in, as has been done for Duchenne's muscular dystrophy and other diseases. There's a study from Lexio, which it's cardiac target. It gets the skeletal muscle probably and dorsal root ganglia, but those do not influence the neurologic phenotype very much, at least in theory. But it could correct heart disease. Their data look pretty good. They're moving on to the next phase of studies right now. The results show everything that you can ask. But as Dr. Kamdar talked about, cardiomyopathy in FA is a long-term proposal. Whatever data you have at 1 year is not going to tell you perfectly what happens at 10 years. You're just going to have to wait on the edge of your chair and see that things are going the right way until you get to the eventual goal. There's a new gene therapy which opened recently. They had a press release that they dosed their first individual about 3 weeks ago from solid uh, therapeutics. The study is called Falcon. I could go with the joke on why did they name it after the Falcons? Why couldn't they name it after the Patriots or the Seahawks winning teams? But that's up to them. Uh, but with that said, they do two injections simultaneously. That gets around the one and done problem with gene therapy, that because of antibody formation, you have to do everything at one time. They give an injection peripherally to get to the heart and centrally into the cerebellum to restore frataxin levels in the cerebellum. Good idea. Let's see if it works. Because in the end, we rely on data. There is one thing we must note is that I mentioned that the motor neurons will go away in FA long term. You won't get to those neurons with this injection. They're too far forward. So the amount of recover benefit you would have in that system is unclear. So this may be a very good therapy, but it will not reach the four-letter word cure because it simply doesn't get everywhere. That's why we have accessory therapies, and that's why we keep working on other approaches, small molecules and things like that. The last way to restore frataxin is to reactivate that gene, override the GA repeat, just make it like it's not there. There is a company that is doing this, Design Therapeutics. Their drug is DT216B. In a dish, notice what I said. On cells in a dish, it works really well. How well does it work in people? They have an ongoing phase 2 study, dose finding in Australia right now. They have filled up their cohorts through the summer, but they are still perhaps looking for more. They would like to come back to the United States next year. We'll see how the regulatory agents let them go. But that's another approach to get frataxin levels back. It's even possible that this could be used in conjunction with things like nomlabofusp Lexeo gene therapy or solid gene therapy or other gene therapies that occur. We don't imagine that one thing will do it all. Oops, I went the wrong way again. Call me wrong way, Dave. This reminds me that gene therapy at this moment is not perfect. We want to reach the retina to keep people from going blind. So we have lots of targets we want to address. I can imagine that there will be multiple. We'll probably need to have ongoing development of small molecules. If you wish to stay abreast of these things and or participate, there are various things you can do. Follow on the Friedreich Ataxia Research Alliance website. They post updates all the time. They have a registry where they will notify you of clinical trials that have, or other clinical studies, even if they're not trials that have come about, as well as their Facebook page. Ask your doctor, particularly if they're one of the people who are participating in Unify, the natural history study sponsored by FARA. Those 35 individuals in the world see almost the majority of individuals with Friedreich ataxia around the world. You are also all free to email me anytime. Even if I don't know you, I will respond. I may not be able to answer your question, but I'll do my best. There's my email right there. I think it's probably out on the web, probably on the dark web. Who knows where it is these days? And of course, consult clinicaltrials.gov. Every study, every therapeutic intervention in the United States and usually worldwide must be posted on clinicaltrials.gov, and they will tell you if it is recruiting or not, as well as give you the contact information for all the sites. So I want to thank you for your attention, and that was indeed my last slide. I'm going to stop sharing here, and I'm going to take any questions.
Thank you so much, Dr. Lynch, for that informative presentation. Let me get right into the questions here. Oh, I apologize. Let's see here. All right, we do have a couple of questions. I'm going to start with some questions from the chat. What tests should be done to determine if someone is an FA carrier?
So the test that should be done to figure out the carrier is the same one you do for diagnostics, which looks for the presence of the GAA repeat. So it is a reliable test. It's sent to the same lab. It's same labs. It's exactly the same test. It can be sent by any physician. So you don't have to actually, let us say, come to Philadelphia or have a video visit with us. your doctor can email me and we'll tell them where the form can be gotten and they can send it off to Baylor or GeneDx or whatever your insurance covers.
Wonderful. Thank you. Um, Skyclarys does not help some people with FA. Can you explain why?
We call this normal human variability. Uh, Within FA, just as there are different macroscopic phenotypes, some people get more heart disease, some people get more neurologic disease. They tend to correlate because they come from the same genetic mutation, but that correlation is very imperfect. Just as that occurs, the same microscopic or molecular phenotype varies. Skyclarys works to increase the levels of a transcription factor called NRF2, which protects all of us against free radical disease. In some people with FA, they paradoxically downregulate that more than others do. They would be the most responsive people by logic. It could be that that's what it is. We don't really know at this point. I'll say this, having treated about 300 people, it's not usually side effects. We can usually manage around the side effects. There are some people who do seem to respond better. It is not purely stage of disease because I see the next disease, the next question is about would things be affecting someone who's no longer ambulatory? Uh, People who are non-ambulatory, in my opinion, may note the biggest benefit from Skyclarys. It could reflect their disease stage and how readily they notice things or how experienced they are. But even beyond that, there's variability. We do not understand it. If we understood it, then we would know another target. So we're always looking to go back and do that and reassess such things.
Great. Thank you so much. Let's get on to the next question here. If a patient is on Skyclarys, when can they participate in the genetic trial?
So Skyclarys is an approved medicine. Uh, you can only do one experimental medicine at a time. And an experimental medicine is basically defined as being part of a regulated experiment, whether you're on or off it. Some you could even have coenzyme Q can be an experimental medicine, even though it's a vitamin. Skyclarys is no longer an experimental medicine. It is an approved medicine that people are taking. And thus, you can participate in any add-on experiment as long as it is within the inclusion criteria of the study as set forward by the person who's running that study. At this point in time, it would be very hard to defend a trial for adults with FA who were not allowed to go on Skyclarys unless Skyclarys had a direct drug interaction with the substance being studied. And Skyclarys does not interact with any of the gene therapies. It does not interact with nomlabofusp to my knowledge, and I don't think it interacts with vatiquinone, although some of these haven't fully been studied.
Great. Thank you so much. It looks like we do have a lot of questions coming in about Skyclarys. Another one is, what has Skyclarys shown in terms of cardiomyopathy? Is it too early to draw conclusions, or do we know that it does or does not slow the progression as well?
So that's a really good question. The answer is we don't know, but I will tell you my own personal review from 300 patients. I will mention you monitor BNP values, as Dr. Kamdar mentions, that's in some ways a stress hormone. Well, it looks like that Skyclarys actually simply makes the atrium more responsive to pressure. So if I took some Skyclarys, even though I don't have any heart disease, my BNP levels would go up. It's something which has nothing to do with heart disease at all. So we're going to discount that. If you look at the echoes, and we have followed echoes after the 300 people we have started on Skyclarys, and I will admit I only went back and manually looked at the last 200. I would say that most people had absolutely no change. They did not improve. They did not get worse. Now, some people got a little worse and some people got a little better. That's again random human variability. And I suspect the people who got worse were about to get worse anyway. And the people who got better might have been about to get better for a while anyway. So right now it's too early. I will weigh in that it's probably not going to do a huge amount either way. I think if it did something really bad, we would have noticed by now. That's for true. I will also know we will get calls of someone whose ejection fraction is acutely uh, changed after they started Skyclarys. In almost all cases, we can identify a different cause. They got viral cardiomyopathy or something like that. So my impression is it probably doesn't do a whole lot either way, and we're just going to have to wait.
Great, thank you for that answer. Someone asked, should parents of children with FA be tested for research reasons?
Uh, all, so parents of people, there are very few, if any, new mutations in FA. So parents are obligate carriers. We treat you as if you're an obligate carrier. If we inadvertently figured out that you weren't, oh, we probably would have asked you in advance, did you want to know? There are famous cases of individuals where we do not test parents. We someone isn't randomly a carrier, we don't really want to know it. We'll stay out of that situation. But this new interrupted repeat gives rise to the possibility that we will inadvertently find in people who are real carriers. We will treat you as if you are a carrier and treat the data appropriately. We wouldn't retest you. Uh, and the only time it becomes, and in fact, let's suppose if you have a child with FA, suppose the siblings who don't have FA, they may be carriers. In fact, there's a 2/3 chance that they are carriers. So when they get married, if we're worried about having a child with Friedreich ataxia, we don't test them because the 2/3 chance is going to be positive. We test their spouse. We like to see negative results. We don't get anything out of we don't get any, we're not happy when we find someone we expected to be a carrier to be a carrier.
That all makes perfect sense. Thank you so much. Um, Another question is, do you know of any support groups for FA parents and families? And I can add on to any answer that you have.
Okay, so Sarah's going to tell you a little bit about the MDA support groups, I imagine. If you go to the FARA website, they have a series of chat groups for teenagers, for younger children, for parents. I know I saw the name Paul Conans above one of the chat entries before, who runs the Advanced Ataxian uh, chat group, if you're still on Yahoo, as well as the Friedreich Ataxia Parents Group. There are lots. Remember, find the people whom you can communicate with and trust. Remember that not everyone at the end of a chat group is in your situation. I would also, FAPG, as Paul notes, is an email group for parents. So connect with the groups, find the ones. Do not get your medical care off of chat groups. That's an aside there. Uh, get the ideas and ask your doctor whether this makes any sense. I have found a lot. I will note the whole entry of omavaloxolone into the FA field. It didn't come from a scientist. It came from a parent. So the ideas are frequently good. They just need to be uh, vetted a little bit. So figure those things out and go from there. I see Marissa has also put up in the chat the MDA group, and Paul has
Yeah,
put up the FAPG there.
wonderful. Thank you all for sharing these resources with us in the chat. That's one thing I was going to say is MDA community groups. You can see that linked in the chat there. We do have adult community support groups and pediatric community support groups. And then I also just wanted to draw attention to the MDA Connect video appointments. They're 30-minute video calls with an MDA specialist. They might be able to help you find something more local, or if there's another virtual option, they can help connect you with those.
I would also remind people, National Ataxia Foundation has support groups that are locally based. They are not disease specific. So sometimes it will be largely, in some communities, largely FA patients, and other communities, largely spinal sulbar ataxia patients, and in some communities, largely idiopathic ataxia patients.
Yes, thank you for that disclaimer. Yeah, so there's a lot of options. So give us a call and we can help you out. Dr. Lynch, I'm going to do one more question. Um, let's see here. What are the treatments on the horizon that you are most eager to see come to clinical
Ooh.
trial to significantly alter outcomes?
So, these are all potential good treatments. Uh, Many years ago, right when the gene was first discovered, they said, "Oh, this is a simple disease mechanism. We should be able to treat this right away." Life is never as simple as you think it is. And more the more we learn, how there are new approaches. The best treatment should be we'll put it this way: restoration of frataxin levels, if done early enough, in sufficient amounts, in the right cells, for a long enough period of time, without significant side effects, should be the best therapy. Which of these therapies, which we talked about, did I describe? Either none of them or all of them. You could make a case that you mix all of them together and what you come out on the far side is exactly what I wanted, but I'm not sure you can mix them all together. Clinical trials are about parsing out which ones are best when. And it may be that the ideal treatment for one person, and I shouldn't say it may be, it almost certainly is true that the ideal treatment for one person is not the ideal treatment for someone else. That is the value in looking in so many different ways as the field is done and doing systematic, well-performed trials, not cutting any corners so that you know what the real result is in the end. That said, in 50 years, I imagine we're treating everything by gene therapy. I hope to see that but I imagine also either protein replacement and the epigenetic therapies may have equal value at that time. So in 50 years, where you can come to the FA program at CHOP, and we'll see which one of those three basic frataxin replacement approaches is looking most promising. So at that point, I'll be 116. I'll still be there, and we'll go from there.
Well, we'll make sure that everyone puts that date on their calendar, Dr. Lynch.
Yeah, I'll send out a calendar invite later today, guys.
Wonderful. Well, thank you for making yourself available for
Thank
quite
you.
an extended period of time and especially for today.